Hello, and a very warm welcome to everyone joining us for today's Select Science webinar, Integrated Solutions to Manage Your Biorepository and Maintain High-Quality Data. My name is Sarah Thomas, and I will be moderating today's presentation. I'm delighted to be joined today by Carla Poulsen, Senior Product Manager in Life Sciences at Abbott Informatics. Today, Carla will discuss the features of the STARLIMS software solution for biorepositories and biobanks, and how this enables you to support the entire sample lifecycle, from collection and reception to sample access and storage, chain of custody, and sample shipment and packaging. After the presentation, we'll move on to our question and answer session, so please feel free to ask any questions for the Q&A session at any time during the webinar, and you can do this by submitting your questions to the left of your screen. Just click on the purple tab. So without further delay, I'd like to hand over to Carla and to thank her for presenting to us today. Please go ahead, Carla.
Thank you. Hi, everyone. I'm going to skip the introduction since I was already introduced. So I'm Carla Poulsen, and today I'm going to talk about sample management and the needs for biorepository solutions. This is going to be more focused on the data and information side. So let's start first by understanding biorepository data. And I'm going to show you something that perhaps some of you already have had in your mind. This show me the data question is something that in the context of biorepository, we are going to perhaps going to have questions like, where are my samples and where is my sample data? And so that is important to understand because when it comes to biological samples, whether they are in a liquid form or solid form, so there is going to be multiple stakeholders or perhaps IT systems where this data is going to be either coming from or is going to be needed for different purposes. So for instance, we can have CROs that need sample data and that can also add more data to our biological samples. Of course, a biobank could also is going to have a lot of the data related to the samples. But we can also have some of these samples data in other software systems, such as a genomics bioinformatics software, or perhaps a slide images analysis software. So more specialty software solutions that will also need to have access to the sample data and will aggregate more data to it. And of course, different entities like perhaps researchers, study-sponsored clinical sites, or ECRFs are also going to be needing data access to the data for these samples. And what makes it complex when it comes to biological samples is that many of these, they come from different clinical trials and multiple research projects, or perhaps multiple qualified suppliers or collaborations. So depending on from where they come, we are going to have not only different data, but also the workflow for handling these samples could be different. And of course, the data as a result is going to reside perhaps in multiple different systems. And not only that, if the samples themselves could be stored in multiple locations, and sometimes they could be in transit status, especially when there are shipments of samples, right? So all of these makes it more complex when it comes to biological samples. So knowing these 5 questions, the who, where, when, how, and why, these are questions that are very much related to inventory control. And when it comes to biological samples, we can go through different processes, and we need to know all of these data for these questions from the moment the sample is collected, the metadata that will be associated to the sample, the moment that the sample is arriving to the lab and the reception has to occur, the storage of the samples, if there is any test analysis, analytical data that will be gathered for the sample, and the processing of the sample, and all of these things, and there could be even more events. These are just a few examples of typical events that happen to the samples. We need to keep this chain of custody. So STARLIMS, which is the solution that we have for in Abbott Informatics, gives you all of the answers to these questions for every event, for every process that you have to do to apply for your samples. We keep all of this information centralized. But also when it comes to the processing, there is this other piece of information, which is the sample genealogy. Why? Because we're going to need perhaps to do aliquots at some point, or create derivatives, or perhaps even have pools of samples. So the relation of the parent and child in the biological samples is really important. So having the chain of custody and having the sample genealogy are going to be very critical features that the LIMS solution should have for BIOREPOSITORY. But still, all of these is very much related to inventory control. So how do we go beyond the inventory control? And specifically for biological samples, it's not enough to just keep track of, let's say, I have a material, I have a tissue sample. Well, a tissue sample could be associated to different matrices. And I have just put here a few of the most common ones. So perhaps this sample could be associated to a human, to an animal, or even to a plant. And depending on the type of matrix that this sample is associated, we need to capture different metadata, different perhaps even classifications of the sample. And knowing all of this data is really important, because at the end there is going to be all of this data aggregated. It's coming from some kind of perhaps clinical study or research project, or perhaps it's associated to an experiment, and that experiment has a protocol on how to what the tasks are going to be applied perhaps to the different samples. And having all of these metadata is going to be very important. So in the case of human, for instance, we could have patient data, and when it comes to patient data, it could be something as simple as just a patient ID that doesn't have any relation to any PHI data. But we could also have, if needed, also PHI data, if depending on the laboratory needs. Typically, when it is research, we don't get much of that. So it depends on the needs of the laboratory. The consent is another piece of information that it's important when it comes to human samples, and these consents typically are going to be associated to the different clinical studies. There are going to be different consent forms that we need to track for the patients, or the subjects associated to the clinical trial. But also we have needs for keeping these biological samples for animals. And there are many cases where laboratories, they also carry on clinical studies with animal samples. So this is very common on the preclinical trials. So this is also important to understand that we have to support different classifications, and in the case of animals, a species is not enough. We have to also maintain and manage a hierarchical classification of the strains for the different species. And very similar will be for the plants. We have many customers that have also the need for a biorepository solution, and in their case of specifically the biotech industry, it's going to be very common to have, for example, the crops classification and the cultivars. So, and this data is very, very important when it comes to their experiments, their research experiments. So this is why it is not enough just having a classification of a sample type. It has to go beyond that. So I'm going to now show you a typical biosample workflow, and this is going to be more in the context of a clinical trial and research purposes. And I think probably many of you are familiar with the concept of the kits. So kits for sample collection. This is something that many labs, they do offer this feature of kit production. So they have the need to prepare these kits. So the kits are going to be basically considered kind of like a consumable. It's just a material. And for purposes of keeping the inventory of that material, inventory management solution is pretty good for that, right? Because it is just a consumable. But the kit, what makes it unique is that you need to define what is going to be the components that will be part of this kit. And when it comes to the components, then you can have different perhaps sample containers that you want to have in your kit. And you may want to also have barcode labels perhaps printed for your containers. And also there could be the need for having a paper requisition form that will be attached to the kit. And so all of these data, all of these inventory data, the LIMS should be able to track, not only for purposes of tracking your consumables and your production of your kits, but also when you need then to ship those kits to the different clinical sites. So in this case, for instance, once you have prepared them, you have them in inventory for your kits, you can then use a transaction from inventory solution such as shipping to indicate the destinations for the different kits. Now let's say at this moment the kits arrived to the clinical sites. Clinical sites already have the kits, and they are going to start now collecting the samples, whether they are patients, which is going to be the most common case, but sometimes we could even have, animal samples also being collected. But let's suppose we are getting now the samples collected in these kits. At this moment when the sample collection is happening, these consumables, these containers that were intended for the sample collection are no longer anymore just a consumable. It is now becoming a biological sample, and all of the collection data associated to it will need to be part of it, and that is something that could be collected perhaps in a paper form, the traditional way, like if somebody has to be entering all of this data manually in a paper form. But there could be also other better, more efficient ways to collect all of this data. The idea is that all of this data at some point, it needs to be coming to the lab, and these samples are going to be shipped to the lab. And when the shipment of samples arrive to the lab, the LIMS solution should be able to, in this case, if the samples, the kits were created in the LIMS, then we should be able to recognize and reconcile and say, yeah, now we got the kit back. And with that, there could be additional information that the LIMS would know, such as the clinical study, the study perhaps time point associated to the kit, and be able to expedite the logging information for the kit that was received. And now I'm going to show you a screenshot. This is of our solution in STARLIMS that allows you to just a quick example of how we could define a kit. So here we have our trial manager application. You have your trials, and we have here at the bottom the option of defining the kits and the components, where you can basically define what are going to be the materials that are going to be part of your kit, how many we're going to have, whether we need to have barcode labels generated for those, how many barcode labels we need to print. So all of this definition is really important, and you can define that for your clinical study and then associate it also to a specific time point as part of your study schedule. Now I'm going to show you a quick video clip of a solution that we have for in our product for creating these kits. So right now, this is showing us the kit creation transaction that we have in STARLIMS. You can define how many kits you want to create, and the system is going to tell you how many components you need based on the number of kits, and allows you to select the inventory, the lot number for each of the components, and it will consume from those inventories the quantities that are going to be used for the kit production. You can select the location, the expiration date for your kits, and basically at this point also you can perhaps check if you want to print the barcode labels or just leave it as that. The transactions that we have in our system then will be basically all tracked here. You have all your inventory of kits, in this case, are going to be associated to a clinical study, and that inventory will be now available for you to perhaps maybe move them to other storage locations or ship them, which is going to be the typical case that once you create these kits, it's because the next thing you need to do is to ship those to the clinical sites for the sample collection. Now I'm going to show you another solution that we have in STARLIMS, and this is a video clip of the use of our mobile app for sample kit collection, where we are scanning with the mobile app the kit, and by that the system is recognizing the study associated to the kit, and it also shows how we scan like the subject data. You can enter the information of the sample, basically all the sample collection data that you need to enter perhaps in a paper form. You can do it with a mobile app, and even allows you to take a picture of the sample and associate it to the sample collection. So this mobile app is just an example of a solution that you could implement for in your laboratory, and it will expedite tremendously the time when the samples arrive later on. All of these sample collection data would already be available in the LIMS, reducing the room for error when transcribing from a paper to the system, to the LIMS, and also making it faster, to receive the samples. These mobile applications can also be available in two modes, offline and online mode. So for instance, if for some reason the clinical site or wherever the sample collection is done, there is no connectivity to internet, this information can also be loaded in offline mode, and then eventually once you get connectivity to the internet, all the data from the mobile app will be submitted and pushed to the LIMS. So that was the first workflow for, let's say, the sample kit preparation, the production and collection of the samples. Now, let's suppose we have all of these samples arriving to the lab, and this is another very important process as part of the biological sample workflow. The samples arrive to the lab every day, and we need to receive them. So this shipment reception is a process that typically a user is going to have some kind of barcode scanner, and will start scanning the barcode labels. In this case, it could be the shipment barcode label itself. Perhaps the tracking number has a barcode, and or perhaps we can also have the kits themselves with barcode labels, or the containers themselves with barcode labels. And another option also could be that we have a solution in STARLIMS for defining your requisition forms, defining a template for your requisition forms for generating 2D barcodes. These are electronic requisition forms that you can also make available to these clinical sites and any a customer that does sample collection, and instead of writing in a paper, you basically have the user fill up all of the data in an electronic form, and as the data is being filled up, the data is basically having these 2D barcode labels generated in the form itself. The user prints the form, and by the time that we receive these samples, the user, all they have to do is just scan the barcode labels from the e-requisition form, and with that, the data will be already in the system, reducing manual data entry errors and also time, right? And at this point, let's say, any of the ways that we can have, for scanning, any of the barcode labels that potentially we could have in the system and be able to reconcile and say, yes, we have it. There needs also to be a solution always for what if I get a sample that has no barcode label. So there is always a solution for that. So you can as well manually enter whatever is the ID of the sample, or do a manual, like an ad hoc login of the sample that you received. That would be perhaps the exception. So, but especially for laboratories with high volume, you need to have a process in place for your shipments that allows this to be done in a very efficient way. So, so we have many solutions for that. For the reception, another thing that the LIMS needs to do is have a validation of the items. Obviously, every time that we either scan or enter manually some kind of ID, the system is going to check whether it knows about that sample, that kit, or that shipment. And if it has that data, then it will be successfully validated, and it can be basically acknowledged in the system that it was received. But we can also get some problem samples, perhaps in this reception, right? And as the LIMS should provide a solution also for handling those problem samples, like perhaps this kit we don't know, or we have no idea about this shipment, and allow you to handle those later on. It shouldn't stop you from just keep scanning and receiving the majority of your samples that should be good to be received in the LIMS. So we need to also have these options, for handling problem samples. And with problem samples, there could be also another category of quality control. I think this is also another option that LIMS should offer for the users as they are receiving samples, to be able to capture quality control data for the samples that they receive. And this quality control data, the way we have it, at least in the STARLIMS, is you can configure all the list of reasons or issues that it could be for quality control, such as the sample could be leaking, or is lipemic or hemolyzed, etc. And you can have all of these quality control as a list of options, so then the user can check, okay, this is the quality control issues that we have received on this sample. So now I'm going to show you also another mobile app solution that could help for shipment reception. So why we have this? Because many times when if you think about the space where these shipments are being opened and received in the lab, it's not like you're going to have a desktop right next to you. So having a mobile app where you can scan the tracking number or the shipment ID is going to be very handy, so that as you are scanning those with your mobile app, you could be then receiving and validating with the system, with the LIMS. Yes, we know about the shipments. They can be received. We have them now, and basically say, yeah, we got them. So this is something that I think many of our customers, they already use this mobile app. We have this in our content library, and it could be taken as an example, and of course it could be modified for each customer needs, but that's the main idea of trying to use mobile solutions for things, activities that real time, that provides a value for real time tracking, and shipment reception is definitely one of them. Okay, now I'm going to go over the next workflow. Processing and sample management and processing is going to be the next thing. So let's say now we have our biological samples. Let's say we have them in the lab. They are stored, or they are perhaps in the benchtop. They just came, and now there needs to be a whole different workflow or workflows that these samples have to be routed depending on different, perhaps could be clinical studies that dictate the sample management and processing plan, or sometimes we could have a laboratory that is just very simple. This is the sample management and processing plan for all our samples, regardless of clinical study. Or perhaps you may want to even do this based on sometimes could be the test that was ordered, etc. So there could be different conditions and situations that the LIMS solution is going to have to account for in order to say what is the next thing to do for these samples that we just got them, that we just received them, they are, let's say, in the benchtop, and now we have to determine what to do next, and we have to provide hints to the users in the lab to let them know these are the samples that perhaps they need to go to storage. So that could be one option. Perhaps we could just receive samples that all they need to be done is to be put in perhaps a storage container, and from there they may need to be put into a -80-degree storage location, for example. And so being able to give them that reminder, these are the samples that need to be stored, it's important. But also there could be other different workflows based on the sample management and processing plan. Samples may need to be perhaps aliquoted, or perhaps we need to create derivatives for these samples. And when it comes to aliquots, for example, it's not just enough saying, okay, we are going to just need, for example, this many aliquots. We need to indicate the volume of the aliquots, the container where these aliquots are going to go to, and so it's all of this information that needs to be defined. And also the derivatives, similar to the aliquots, we will need to indicate what is the outcome material, the outcome sample type that we're going to capture here, whether it's going to be perhaps a DNA or RNA. So those are like the typical examples for derivatives. Like you can have the nucleic acid extractions, but also you could have, in the case of the tissues, like you could perhaps have as a result slides for preparation. And all of these processing, then it may not end just with creating the aliquots and creating the derivatives. It could be that all you do is just that and then have them put them in a storage, but it could be that the samples, they need to go for testing, right? And so that's another piece that the LIMS needs to be able to consider, that it's perhaps the aliquots or derivatives that they need to have. We need to collect analytical data, right? And in some cases, we are going to also receive the samples as just already as we are, the way we're getting them. Perhaps they are, those containers are coming ready to be tested, so no aliquots, no derivatives, they need to be created. So we need to also account for that scenario. So having the LIMS telling the user all of these reminders and cues, telling them what needs to happen next to the samples as soon as they are received is important. Now, I have to say that we have also some customers that it is not like a very predefined plan, like we know this is what we need to do. There is always a solution for the need of having ad hoc services, or perhaps processing needs that you need to do for your biological samples. So STARLIMS offers that solution as well. So it doesn't have to have a predefined plan, but you can always ad hoc just select what are the things that you need to do for your samples, whether you need to do aliquoting or perhaps all you need to do is just testing, etc. Okay, so then as I'm mentioning all of these sample management and processing, one of the potential solutions that you could ask for your LIMS is to have also integration with automated storage systems. So in the case of biobanks, this is going to be very common, and I'm putting here an example of the Hamilton BIOS, but this could be any other automated storage system. Something that would facilitate an integration is an API. and we've done this integration with the Hamilton BIOS in the past, and they have an excellent API. And an example of this integration is, for example, letting the Hamilton know that we are going to be storing samples. So we're going to be pushing some sample data from STARLIMS to the Hamilton. And we could also get basically have a pick list of samples the way you want them positioned in perhaps in some kind of in a container, and have that pick list pulled from the automated storage system and have it ready, available for the user. So these are just examples of integration and the communication exchange that could be done with automated storage systems. So just wanted to show you that other potential solution that you could look in as part of your sample management and processing. Okay, now let's move on to another workflow. Let's say now we have a request to ship the samples back perhaps to the sponsor, or perhaps we need to ship this to a researcher. And sometimes we also have laboratories that they need to outsource samples for could be for testing, it could be outsourcing for additional services that they need to be done for the samples. Whatever is the reason, when it comes to the sample packing and distribution, the LIMS should be able to allow you have some kind of report when you have to pick your samples, pull the samples from the different locations where they are. So having a pick list report for all the samples that you need, let's say, to pack, it's important. So this is where perhaps an integration with an automated storage system could come very handy. But if there is not such let's say integration, we could have regular perhaps freezers or coolers, storage locations that all we need is to provide this report to the user, so at least they know where to get the samples. And once they have the samples, the next thing could be to put them in some kind of container. So in this example, I have here like a shipping container. This is a 5x5 box, for instance. You can define different layouts for your shipping containers, and then you can have and say, okay, this is where I'm going to put my samples. And part of your pick list also could be to even define, okay, I need to put these samples in these specific positions, because sometimes a researcher could be asking the laboratory, I need the samples in this type of container in these specific positions. So it could go as granular as that. And all of this data, that the pulling of the samples, shipping, putting the samples in some kind of container for shipping, all of these processes are being tracked in STARLIMS. Remember the chain of custody data, that the who, the when, where, all of these questions, are going to be captured in this in each of these processes. And once we are ready to ship to perhaps a CRO, whatever is the destination for the sample, also having the ability to select the shipping carriers and even to integrate perhaps with these shipping carriers could be also another option that we can have as part of the sample packing and distribution. So now I'm going to show you another video clip of a mobile application that we have in our content library, and this is for sample picking. This is basically telling you, giving you the option to scan your barcode of the sample and scan the location where it has to go, and it tells you exactly this is the position where you have to put the sample. So this mobile application is also going to be very useful, because when the user is doing all of this picking of samples and packing, you want to track all of this data in real time, as opposed to then after you've done, then you go to your desktop, and then whatever you just did, you have to replicate in your desktop. Because all of these transactions that I'm showing you with the mobile application solutions, it's available in the desktop solution of our LIMS, but it's just the advantage of doing all of this in real time as you are doing your sample, you're handling your samples. And as I mentioned, also a potential integration with shipping carriers if the customer is interested also in knowing at all times where the samples are. That is also possible, and it's we have some customers that we've done this type of integration. FedEx and UPS are the most popular shipping carriers, and they have great APIs that are exposed for other systems to use, and we've done that. So we can, for example, send shipment information to the shipment carrier, and then we have also the ability to get these tracking updates, so we know at all times, okay, where the sample is and when it arrives to the destination. This could be very useful also for laboratories when they do shipments of samples from internal sites, different locations that a laboratory could have, but you want to track when it made it to the destination, to the other internal site of the laboratory. Now, as the last example of a typical biological workflow, I'm going to talk about the sample disposition. So sample disposition is something that at some point is going to be needed, and it could be triggered by different events. Perhaps there is an expiration date to your samples that could be driven by perhaps the retention time, or it's just the stability of the sample that dictates that expiration date. And in any of these cases, the LIMS should be able to give you a report of samples that are ready to be disposed. And it's not just enough to tell these are the samples, but also the locations where they are. So then a very similar process to the packing needs to be done. The customer or the user needs to basically go to these different storage locations, pick up the samples, and that are ready to be disposed. And so this is something that the LIMS should be able to provide, to the user. And as they are then scanning the samples or marking them for disposition, other validations need to happen as a prevention to make sure that the system is letting the user know whether these samples, are good to be disposed. Validations can be done, for instance, to check if the sample has any kind of tests that are still perhaps either pending to be either resulted or released, or perhaps the sample is marked as on hold. Whatever is the reason, we could give warnings to the user. The LIMS should be able to prevent and make sure that if the user is okay to proceed with that sample disposition. Now, the sample disposition doesn't mean that we are deleting the samples. The LIMS should never delete the data of your samples. It only should update the status of your sample, meaning that after the sample has been disposed, you know who disposed it, when it was disposed, the reason why it was disposed. You should have all that information, and the history of the sample will remain in the LIMS. Everything that happened from the moment it was collected, arrived to the lab, and everything that sample had to go through the whole chain of custody. Okay, so now I'm going to show you a quick video. This is going to go over different solutions that we have for biorepository in STARLIMS. So I mentioned, for example, the storage containers, the capability of defining storage containers in your LIMS is important, defining the layouts and be able to store your samples in these different storage containers, whether the transaction is being done via a mobile app or via the desktop, which is what you're seeing right now. And having at all times, for every transaction, anything that you do to the sample, that information available in the chain of custody is something that we have in a STARLIMS. Also, the transactions and that many of transactions that you see in the system can be limited based on role access and sample type. And here is an example of a typical transaction that allows the user to move samples to a specific storage location, storage container. And here, for instance, you can see the electronic signature that you can also enforce for each of your biorepository transactions. This is something that it's optional. This administrator can configure what transactions will require electronic signature. And here just more examples as we are doing things to the sample. We can see the chain of custody, information being updated, and having all of these events basically that happen to the sample. Being able to define storage locations and do, for example, this aliquoting of the samples. And in this case, the electronic signature, for instance, looks a little bit different. It just asks me for a reason. So here we have the aliquots created for the samples, and we can see also the sample genealogy for the aliquots that we just created. So this is something that all that you are seeing is out of the box in our STARLIMS product, and many of these transactions and these solutions, then we use them with our customers according to their needs for other perhaps sample workflows that they need to have, depending on their perhaps clinical studies or whatever is the laboratory needs for managing their samples. And so another important thing is is the capability for integration. So as you can see, when it comes to the LIMS for biorepository, it's not just going to be the LIMS. So as when I showed in my very first, in the beginning of the presentation, the sample data will be dispersed in multiple IT systems. So the LIMS is just going to be one of them. And having capabilities for integration for the LIMS with other external systems, or perhaps the automated storage systems or instruments or shipping carriers, anything, it's very important. So when it comes to that, STARLIMS has the ability to integrate by the traditional file exchange. This could be done via a shared network directory, but we also offer that with secure FTP because we have also our solution available in the cloud. So when we need to access the laboratories network, we use that secure FTP. And we also have a solution for SDMS, and this is many times used for our file-based interfaces. SDMS allows us to handle structured and unstructured data from the files, and it could also be used as a document management. So, so basically, these solutions are part of the STARLIMS integrated suite of solutions. Web services. Web services is another thing that we have as part of our capabilities for integration. So the STARLIMS product has already its own API with some functions for other external systems to integrate with. But this is not just a STARLIMS API. It's sometimes it's the other systems or other instruments, perhaps, that they do have an API. So we can always consume, we can always use their APIs, and that's actually a preferred method for integration. When there are APIs available, it's very simple for us to just integrate with that external system. And once you have, let's say, all of this data centralized, in your LIMS system, as you can see, all of the data that I've been showing you is just data. But once we start getting, for example, the analytical data with the samples and do more analysis, that's when we start unlocking the intelligence and getting maximum scientific value out of that. And having that data in a advanced analytic dashboard solution like we have, like what we have, it's really what provides the value to the laboratory, because this allows you to see now the information at a high level overview, and will help you to leverage all of this data that now is transformed into valuable information and help you, for your future analysis. So this is basically just I'm almost to the end of my presentation. STARLIMS is being in the market for many years already. So our LIMS solution has a different list of solutions, not just the LIMS. So we have STMS, we have ELN, the mobile solutions, the advanced analytics, we have our solution available in the cloud, and we have this content library, which we put very often. We try to add more content, such as the mobile apps or of the dashboards for advanced analytics. And just recently, we added also examples of workflows. And so this is something that we make it available to our customers. So just wanted to give you a final summary of just a glimpse of all the different integrated solutions that we have as part of STARLIMS. Okay, so now I'm ready for Q&A. Any questions?
Thank you, Carla. Thank you very much for a very informative presentation. So as you mentioned, it's now time for the question and answer session. So we've had a few questions come in. If anyone else would like to ask a question, you can do so with the button to the left of your screen. So Carla, the first question, what interface does STARLIMS support for nucleic acid extractions and quantification?
Yeah, so for the nucleic acid extractions, we've done interfaces with a nanodrop, we've done with Hamilton the Chemagic Star, we've done just recently with the biotech epoch. And what we are trying to do here at STARLIMS is that we have all these different interfaces because every customer uses different instruments for their nucleic acid extractions and quantifications. We try to put them as part of our content, internal content. So if we have a customer that uses, let's say, an instrument that we already have done an integration before, we don't want to start from scratch. We already leverage that integration. So That's another kind of content that we're building an internal library for integrations with instruments in the STARLIMS.
Great, thank you, Carla.
Okay.
The next question here. So when using the mobile app at a collection site, after scanning the kit, is it possible to scan something associated with the patient information to that kit?
Yes. So we can scan also patient information data associated to it. So in the example that I had here in the content library for this sample kit collection, it's actually doing that. So it could be perhaps a subject ID that we already know, or a patient ID that the system already knows about it. So by scanning that, it will basically, just load the information, but also will give you the option, if it doesn't recognize it, to just enter the information of the subject. So either or. And when it comes to patient data, I mean, this is something that what we have in the content library is just an example, but when it comes to the customer implementation, we need to check what are the customer needs, because not all the customers may have the same patient data collection requirements. So it will vary. If it's research, it's just typically an ID, and that's it. Many times we don't get more than that.
Okay, thank you, Carla. The next question here. On average, how long does it take to implement an external interface with STARLIMS?
That's a great question, because we have to do so many interfaces, and I can tell you that it varies, but it can be as fast as 1 week, and it could take sometimes perhaps 2-3 weeks. I would say that would be the average. Now, it depends a lot on the external system. For instance, when we had to do in a prior implementation an interface with Hamilton, it was amazing that it took just, we were thinking it would take a lot more time, but in a week it was done. Why? Because the external system had a very good documented API, and that makes a big difference. So as long as we have access to either the vendor, and we can get or to the documentation of that external system, this implementation for integrated, integration of interfaces, it's not that complicated. Let's put it this way. Yeah.
Okay, thank you. The next question: does the mobile app support all functionalities of the web version?
Yeah, so it is currently we are in the process of putting more features in the mobile app. So it is not doing every single thing. We are trying to prioritize the transactions that do make more sense to be implemented in mobile app. Anything that helps the user to do real-time tracking of your samples is definitely a good candidate for a mobile app. When you are having to have the user going into this, perhaps sometimes there are even storage locations, and the freezers are like rooms, and so we cannot have perhaps a desktop inside those freezer locations. So anything that has to be done, like in those scenarios, it makes sense to have a mobile app. But there will be also some other transactions that it's not really applicable for mobile apps. So we have to always check what makes what provides more value with mobile app. We are right now in the process also of having, for example, a manual aliquoting processes. That could be also another solution that when the laboratory doesn't have necessarily an automated or liquid handler instrument to do that, and the space is very restricted, a mobile app perhaps could be one very useful solution. But not only mobile apps. Think about also there could be also the touch screen monitors. Sometimes also that is another very good option. So when it comes to the user experience, the UX, we are making good progress. I would say in the last year, we have got a more emphasis on improving the UX. So, and that basically involves where it makes sense to have mobile solutions in addition to what we have in the desktop.
Great, thank you. We have time for one more question. So, how does STARLIMS handle aliquoting when it's done by an automated system like the Hamilton?
Yeah, great question. So in that case, we have in our system, when it comes to aliquoting, we have to provide always the two options, manual and automated. In the case of the aliquoting for Hamilton, it is quite similar to the manual. Why I say that? Because Hamilton allows you to send all of the information, so we already have to have the LIMS needs to calculate and check all the different parent samples that are going to be used for aliquoting, provide that information to the Hamilton of the parent samples and the positions in the containers, and give the information of the expected aliquots, the specific positions also that they need to go in the containers, the destination containers for those aliquots, the volumes of the aliquots and all that. And then Hamilton is expected to execute according to that plan. So the plan that we typically provide manually, we have to feed into the Hamilton. But the thing is that when the Hamilton finishes, Hamilton will just try to aliquot whatever the LIMS tells them to do. But if Hamilton for some reason couldn't aliquot certain samples, then there needs to be an additional check, like a quality control check. So because the interface will be bidirectional, we're going to get all of these aliquots that Hamilton tells us, yeah, I finished them, and we log them in the system, but that's not the end. We need then to have a user should be checking and verifying, yes, everything came perfectly. Because we could have a situation of N2 perhaps that came empty and aliquoted by the Hamilton, but there's nothing there. So having a solution for addressing those exceptions, it's important, yeah, when it comes to automated aliquoting.
Great, thank you. That's all we have time for today. So thank you very much to Carla for today's informative presentation and discussion, and thank you to everyone joining us online and for your interesting questions. If you do have any other questions, please feel free to email me at editor@selectscience.net and I will follow up with your questions. Remember, you can also download a certificate of attendance in the related resources tab to the left of your screen. And if you'd like to listen to today's presentation again or to invite someone else to listen, it will be available to watch on demand in a few days' time. So goodbye and thank you once again for joining us.